Hi children, we are meeting back again with another video of functions. Today we are discussing about inverse of a function. What is an inverse of a function? Inverse is actually the reverse of a function. But each and every function do have an inverse. Only some functions do have an inverse. What kind of functions do have an inverse? Let's see. If a function to have an inverse, it should satisfy two conditions. What are the two conditions? Number one, the function must be a one-to-one. Number two, it must. We will discuss this with some illustrations. What is one-to-one and what is one-to. Right. We'll move on. Look at this one-to-one condition. This is a function. This is the domain and this is the codomain. Right? The function goes from domain to the codomain. Right? This is the domain, this is the codomain of this function. This function is a one-to-one function, but it is an into function, not an onto function. We say a function is an onto function if this codomain and the range is same. That means it doesn't have extra elements like this. All the elements in the codomain are mapped to something in the range. Then such a case is called an onto function. But this one is an into function. Into functions can't have an inverse because this one do not have a corresponding element, because when you take the reverse of the function, this will become the domain and this will become the range. So the range of the original function will become the domain for the inverse function, and domain of the original function will become the range for the inverse function. Therefore this can't have an inverse because this has some extra elements. This is a condition which will be violated according to the definition of functions. And not only this case, this is one-to-one and into, many-to-one cases also do not have an inverse. Look at this. This is a many-to-one functions. Many elements in the domain go to the same element in the the codomain. This is a codomain because this is not there in the range. So if you try to reverse this one, what will happen? This is a one-to-many situation. One-to-many are not functions, right? Therefore this many-to-one has no inverse. Even though this is one-to-one, it is an into case, therefore there is no inverse for that too. Right? Both these mappings can't have an inverse. Let's move on. Now look at this function. I have given a kind of a different shapes, but still the concept is same, right? Now look at this. Right? This is the function fx. This is the domain and this is the range of the function. Function goes like this, right? So this is one-to-one and onto. See, no extra elements. Codomain and the range both are same, right? Therefore this is one-to-one and onto. Therefore this can be reversed. This can be reversed. Therefore this has an inverse, right? So this is the inverse function. This orange color thing is the inverse function, right? This is the inverse. For this inverse function, domain is this range. Remember this concept in future when we are dealing with sums. This understanding is very important, and this is the range. So the domain of the original function will become the range for the inverse, and the range of the original function will become the domain for the inverse. So this is a very essential understanding and a comprehension that you should have. Understand this clearly and cleanly, right? This is a one-to-one and onto mapping, therefore this has an inverse, right? Okay, now we will try to see some examples of how to find the inverse of a function. Now earlier what we studied was what are the conditions for the inverse to exist. Now if the inverse is existing, how are we going to find the inverse function? So it's a very simple technique. I think you have done this in your smaller grades also, right? Look at this now. Our function is fx equals 2x plus 1. In order to find the inverse of this, what we do is we take this fx as y equals 2x plus 1. Then we move on to make x the subject here, or write x in terms of y. Now look at this, how to do it. You take this 1 to this side as minus 1. Now y minus 1 is equal to 2x. Then you divide both sides by 2, right? Then our x is equal to y minus 1 over 2. In this case, what do? We write this as f inverse, and this y is replaced by x. So our f inverse x is equal to x minus 1 over 2, right? And then we will move on to the next second example. We have gx is equal to 1/3 x minus 2, x belongs to R. So step number 1, we write this gx as y. Y is equal to 1/3 x minus 2. Then we write, what we do is we take this 2 to this side, right? Y plus 2 is equal to 1/3 x, and then we isolate x on this side and make x the subject, and in other words we write x in terms of y. So for that we multiply both sides by 3, right? Then 3 y plus 2 is equal to x. Now this is my g inverse, and then I write this one as x. So we replace y with x and x with g inverse. So g inverse x is equal to 3 times x plus 2, right? I think you got it clearly. Let's see some other example. Say hx is equal to 4 minus 3x. Now you can pause this video a little and try it all by yourself, right? So what we do is we write hx as y. So y is equal to 4 minus 3x, and then make x the subject. To write x the subject, we take 3x to this side and y to this side. Then we will get 3x is equal to 4 minus y. When this minus 3x go to this side, it will become plus 3x. When this plus y go to this side, it will become minus y. So 3x is equal to 4 minus y. Then x is equal to 4 minus y divided by 3. This is a multiplication. Go to the other side as a division. So we write now this x as h inverse x, and y is replaced by x. So h inverse x is equal to 4 minus x divided by 3. We'll move on to example number 4. Right. This also I asked you to stop the video and try it all by yourself and then look at the video. Right. First we write our fx as y and then make x the subject. In order to make x the subject here, you multiply both sides by 3, then you get, or just cross multiply this to this side, either way you can say it, 3y is equal to 2x minus 4, right? 3y is equal to 2x minus 4, and 4 is taken to the side, then you can say 3y plus 4 is equal to 2x. In order to isolate x or to make x the subject, we divide both sides by 2, then we will get x is equal to 3y plus 4 divided by 2. Then what we do is we replace this x as f inverse and then y by x. So I will get f inverse x equals 3x plus 4 divided by 2. So this is my inverse function, inverse of this function. Okay, let's look at this. This is a kind of a difficult, not difficult, maths is not difficult at all. I don't like to use that word, I'm sorry, it slipped out of my tongue. This is a different one from the earlier ones, but this also has a certain method of doing. Once you get the hang of it, it's very easy. Right, step number 1 is to write this gx as y. Y is equal to this, and then you go to make x the subject of this. The difference between the earlier case and this is, in the earlier case x appeared only in one place, so it was a simple process of making x the subject, but here x is appearing in more than one place, so there is little bit of work to be done. So step number 1 is to cross multiply this x minus 1 to the other side as y into x minus 1 equals x plus 2. In other words, you multiply both sides of this equation by x minus 1, right? By doing so we can get this. Now we will open this bracket and bring x terms to one side and the other terms to the other side. So we will open this bracket, yx minus y is equal to x plus 2, right? Then what we will do, we will take this y term to this side and this x term to this side. So x's are in one place, we can take the common thing out and make x the subject. Look at this. Then you get xy minus x equals 2 plus y, right? Then what is common here for these two terms? X is common. You pull this x out, then x into y minus 1 is equal to 2 plus y. Then x is equal to 2 plus y divided by y minus 1, right? X is equal to 2 plus y divided by y minus 1. Now we have made our x the subject here, so what we do is we slowly replace this x by g inverse and then y by x. So we can write g inverse x equals 2 plus x divided by x minus 1. X is not equal to 1 here, right? If x is equal to 1 here, you can't do the job, right? Now you will see, I wonder whether you noted the fact that here the g inverse and gx both are same, right? Okay, we'll move on to another example, beautiful example like this. Look at this example number 6. Right, that is also a case similar to the earlier one. So what we do is we take fx equals y, fx is equal to y, and then what we do is we make x the subject. In order to make x the subject, we bring x to one side. So first step all, what we do is we will multiply both sides by 4x plus 3. In other words, cross multiply this 4x plus 3 to the other side. Then we will get y times 4x plus 3 equals 3 minus 2x. And then we open this bracket, right? 4yx plus 3y, 4xy plus 3y equals 3 minus 2x. So what we need is x terms in one side. In order to make x the subject, we need x terms in one side and y term to the other side. So 4xy plus 2x, this guy is brought to this side and this guy is brought to this side. So 4xy plus 2x is equal to 3 minus 3y. Then here x is common, we will take it out. X into 4y plus 2, here 3 is common, 3 into 1 minus y, and then we can write y is equal to 3 into 1 minus x. Here a 2 is also common, we took it out, 2 minus x. Here I have replaced x y in terms of x, and this is then f inverse x. F inverse x is equal to this, given that x is not equal to minus half. If x equals minus half, this will be 0, so that part is not in the domain, therefore we have to exclude that. Right. Example number 7 is what? That is also something similar to that. Let's see. Now you pause this video and try all by yourself. Make fx equals y and make x the subject and see. So this is how you do it. Y is equal to x plus 3 over 2x plus 5. Then we get y into 2x plus 5. Y into 2x plus 5, this is multiplied to this side, is equal to x plus 3. Then we will open this bracket, 2xy plus 5y is equal to x plus 3, right? And then what we do is take this x to this side and y to the other side, because we want to take x together. So then we get x times 2y minus 1, x times 2y minus 1 equals 3 minus 5y. So x is equal to 3 minus 5y divided by 2y minus 1, right? Then we replace our x with f inverse and y with x. So f inverse x is equal to 3 minus 5x divided by 2x minus 1, x is equal to half. Is it clean and clear for you all? Right? This is the inverse of fx. This is not a difficult process. We will take another example. Right. See, look at this. How to make x the subject here. Take y equals x cube minus 1. Then y plus 1 is equal to x cube. Then y plus 1 to the power 1/3 is x. So in order to get the x here, what we do is we take the cubic root on either side. We take the cubic root on either side, right? So we can write it like this if you want. Let's see. This one and this one, cubic root. So this and this goes off, x comes here, this is x to the power 1/3, right? This one to the power 1/3, x y plus 1 to the power 1/3. So now we replace this x with f inverse, and then we replace fx with y with x. So f inverse x is equal to 1/3 this. Okay, right. Okay, let's move on to example number 10. Look at this. It says gx is equal to 3x cube plus 2. Here also the same process. Here also I suggest you to stop the video and then try it all by yourself first. Now you replace gx with y and make x the subject. In order to make x the subject, you bring this 2 to this side. First of all, y minus 2 is equal to 3x cube. Now you got to leave this x term only on this side. So for that, what we do is we divide both the sides by 3. So then we get y minus 2 divided by 3 is equal to x to the power 3. Then in order to get rid of this to the power 3, we take the cubic root on either side. Then we get x is equal to y minus 2 over 3 divided to the power 1/3. So then we slowly replace this x with g inverse, right? And then y with x. So we get finally g inverse x is equal to x minus 2 over 3 to the power 1/3. This is our g inverse. We'll move on to another example. Example number 10. X plus 2 root x is greater than or equal to minus 2. Then we replace fx with y. Y is equal to this, and then y squared equals this. You take the square on either side in order to get rid of this square root. So now we can say y squared minus 2 is equal to x. Therefore f inverse x is equal to x squared minus 2. X is greater than or equal to 0, because range here is greater than or equal to 0. This range will become the domain for this. Example number 11, right? Fx is root of x minus 3 plus 4. X is greater than or equal to 3. What we will do is we will take first of all this to this side, 4 to this side. Y is equal to root of x minus 3 plus 4. 4 is taken to this side. Y minus 4 is equal to root of this, and then square both sides in order to get rid of this square root. So y minus 4 squared is equal to x minus 3, and then what we do is we take 3 to this side. So x is equal to y minus 4 squared plus 3 equals x. So x is replaced with f inverse, right? and y with x. F inverse x is equal to x minus 4 squared. Now here the range is fx is greater than or equal to 4. So this range will become domain for this. Therefore you can say x is greater than or equal to 4 here. Right. I think you enjoyed this video. Please subscribe my video and subscribe my channel and like my video so that I can give you better videos in future. Thank you.